This problem is the problem related with the conservation of linear momentum. In this case, you have a car and a truck moving perpendicular to each other, like for example on the road, and then they collide and moves together, and then you need to find it out what is the initial speed of the car. Let me explain this problem here. Let's say this is your car. This is the car, and it's saying a car heading north, and I'm assuming this is a car heading north. Okay, so this is your car. So this is your car, and we're assuming this is the north direction. This is the north direction. This is the north direction, and this is the south. So this direction I'm just representing here. This is the north. This is the south. This is east and west. This is east direction. A car heading to north collides at an intersection with a truck. This is the truck, and the mass both has exactly the same mass. And this is heading east, and after the collision they move together, so they lock and then move together. This is the car and this is the truck, so they lock and then move together, and the speed, and this speed is v is 28 meter per second. This is given 28 meter per second. This is given, and this angle is also given 46 degree. We call this an angle theta. I'm calling this an angle theta. Theta is equal to 46 degree. So we need to find out the velocity of the car. Let's call this velocity vc, and this velocity is vt. Okay, so all the information is given there, and you need to find out the velocity of the car. So the car is moving along the north direction. We'll call this as a y-axis here. In this case, the total momentum has to be conserved along both x-axis and the y-axis. What is x-axis and the y-axis? We call this as an x-axis, and we call this as a y-axis. So I'm calling the north-south direction as a y-axis, and east and west direction as an x-axis. Okay, let's try to find out the momentum along the y-axis. Conservation of momentum and we're using along the y direction. What is the initial momentum here? So the initial momentum and the final momentum along x-axis and the y-axis has to be conserved. So what is the momentum along the y-axis? What is the initial momentum? This initial momentum is m times vc. This is m times vc. What is the initial momentum along y-axis? This is moving along x-axis. It does not have any component along the y-axis. So the truck initial momentum along y-axis is 0. So this is 0. This is for the car. This is for the truck. I'm just writing down here. This is for the car, and this is for the truck. The truck does not have any y component, the velocity along the y component. So its momentum along the y-axis is 0. Now take a look onto this one. They collide together and moving at an angle. So it does have component along x-axis and it also has the component along the y-axis. So what is the component along the y-axis? So if this angle is theta, so this component would be v sine theta. And this component along x-axis is v sine cosine theta. So what is the momentum? So the total mass is the mass of the car times mass of the truck. Okay, and both masses are equal. So I'm just writing down here the mass of the car plus mass of the truck, and both masses are equal. So this will simply be m times m plus m. This is the mass of the car and this is the mass of the truck. And the velocity along the y-axis. What is the velocity along y-axis? It is just v sine theta. So this is v sine theta. And we'll just solve it now. So this one would be simply m times vc. This is equal to 2m velocity sine theta. And now, so this mass and this mass cancelled out. The velocity of the car would be given by 2v sine theta divided by just 2v sine theta. 2 times, so what is the velocity? The velocity is 28 times sine theta. Sine theta is 46 degrees. Just need to plug in all the numbers here. So once we plug in all the numbers, the answer we'll get is close to 39 meter. I'm just putting 39 meter per second. So this is our the velocity for the car, and we can also find it out the velocity of the truck as well. It is not asking, but you can find it out the velocity of the truck. How do we find it out the velocity of the truck? The same way. So we have to find the momentum along the x direction. Momentum conservation along the x direction. See now, so this truck is moving along the x-axis and this is moving along the y-axis. So the initial momentum of this truck is mass times the velocity. Mass times the velocity. The car is moving along the y-axis and it does not have any component along the x-axis. And once after colliding, it does have the momentum along the x-axis, or the velocity component along the x-axis as v cosine theta. So this is the truck momentum, sorry, car momentum along x-axis, and m plus m times v cosine theta. So from this expression, v times t, you should be able to calculate v times cosine theta. You know the 2, the v is the 28 times cosine theta is 46 degrees. So once you plug in all the numbers, the answer you will get is about, again, 39, close to 39 meter per second. And because the angle is close to 45 degrees, and from there you can predict, and the mass is also the same, from there you can predict the momentum for both truck and the car would be very, very close. That's what you got here. So it makes perfectly sense.